Hello there, thanks for watching and I appreciate you. This is a video in a series of videos showing you how to make a custom character controller that uses rigidbody physics, cinemachine cameras, Unity's new input system, and custom player gravity. In the last video, we looked at some features of our slope handling and made some changes to them. In this video, we're going to give our player the ability to jump. Instead of breaking this down and milking the content in several videos, I'm going to just cram it all into this video. This is going to include jumping, variable jump height, Coyote Time, and jump buffering. We're also going to look at jumping, slopes, and gravity a fair amount, as well as addressing a few features involving these three. So let's not waste any more time and jump right on in. Okay, in our Unity project here we've been working on so far in this series, we're picking up right where we left off in the last video. And as usual, when we're working with anything that we're going to be adding a new input for, let's just go ahead and take care of that input first. So in the bottom left corner, we're going to click on our project panel, Input, and double click on Input Actions. Under our main action map, we're going to right click over in Actions and create a new action. We're going to call it Jump. With this action, we're not looking for just a button press, but rather if the button is being held or not as well. So we're going to want to set this up similarly to our Run action, which is a value any. So we're going to change our action type to value and our control type to any. We're going to click on our binding that is created by default when we create the new action. We're going to drop down Path, Gamepad, and I'm going to set it to my button south. I'm going to hit the plus next to our jump action, add binding, and again under path, I'm going to click listen, and I'm going to use my space key. And we're going to click on space keyboard. Up in the top of our input actions window, we're going to click save asset, and we can close the window. Next, we need to update our humanoid land input script, so down the project panel, again under scripts input, we want to double click on our humanoid land input script to edit it. And in our humanoid land input script, all I'm basically going to do is copy everything we have for the run action, and then I'm going to replace the word run with jump. Okay, so just a quick recap. All I did was I copied the run is pressed. It's a public boolean. We call it jump is pressed. We're going to get it from anywhere. We can only set it locally, and the default value is false. And in on enable down here, we're subscribing to the started and canceled events. And in on disable, of course, we are unsubscribing. And then we have the event handler down here called set jump. And we're getting the current context of the event, and we're setting it to our jump is pressed boolean. So if you haven't been following along with our video series, it's probably all Greek to you. I strongly suggest you go back and you watch at least the first video of this series where we go into the input system itself. We are adding these actions as we go along. For example, you may also want to look at the run video so you can see how we set up the run input action as well. And as always, if you have any questions, feel free to ask them in the comments below. Alright, moving right along, let's go back to Unity. And now that we're in Unity, we can go back down once again to our project panel. And under scripts, controllers this time, we're going to open up our humanoid land controller script. And once again, we're in Visual Studio. This is going to be quite a bit of code, so I'm just going to go ahead and add it, and then we will review it line by line. Okay, let's review the code we have so far. So right off the bat, we create a bunch of variables, of course. They will appear in the inspector panel under the jumping header. They're all serialized fields, so we can view them in the inspector panel and change them as necessary. First two are both floats. One is initial jump force with a value of 750. The second is a continual jump force multiplier with a value of 0.1. The next six are also all floats, and these are our timers and our counters. We'll talk more about those later. And then the last two are both booleans. One is player is jumping, and by default we're setting it to false. And the last one is jump was pressed last frame, and we're also setting that to false. We'll scroll down to our fixed update loop. In fixed update, all we did is we're taking our player move input.y, which again is our player's up and down, and we're saying it's going to equal the result of our player jump function. And we'll scroll further down. Here we are looking at our player jump function that we just made. First thing we're doing is we're creating a float called calculated jump input, and we're assigning it the value of our player move input.y. This is so that we have a local variable that we can modify before returning it at the end of the function. Next, we're calling all of our counter functions. The first one is our set jump time counter function. Let's scroll down and take a look at that. In our set jump time counter function, we are first checking to see if we are jumping and if we're not grounded. If we are jumping and we're not grounded, we're going to take our jump time counter and we're going to subtract our time.fixed delta time from it. Otherwise, we're going to reset our jump time counter to our jump time. Next, we have our set Coyote Time counter. If we are grounded, we're going to reset our Coyote Time counter. Otherwise, we're going to take our Coyote Time counter and we're going to subtract the time.fixed delta time. And our last counter function, we have our set jump buffer time counter. If not, jump was pressed last frame and input.jump is pressed. So if we didn't jump the last time we came through, and we're currently now pressing our jump button, then we're going to reset our jump buffer time counter. Otherwise, if our jump buffer time counter is greater than 0, we're going to subtract the time.fixed delta time from our jump buffer time counter. And in the last line, we're just going to check to see if our jump button is being pressed, and we're going to cache that into a variable so that the next time we come through, we can reference this. And this is basically just a simple way of doing a reset so we know if we let off the jump button or not. So you can't just hold the jump button and keep jumping repeatedly. You actually have to press it, let go, press it, let go. Okay? Now I realize this is probably very confusing at first, and we'll come back through this again and explain in a little more detail, but let's go back up to our main jump function. Back in our player jump function now. Next line, if our jump buffer time counter is greater than 0, and we're not jumping, and our Coyote time counter is greater than 0, then we're going to jump. This is our first initial jump. So we're going to set our calculated jump input to our initial jump force. That's the amount of force we're actually using to move our player up. We're going to set the player's jumping boolean to true. And we're going to set both our jump buffer time counter and our Coyote time counter to 0. And if we don't set these to 0 right now, then technically you might be able to do a double jump the next time this comes through. Moving on, else if our jump is pressed button is being pressed, and our player is jumping, but our player is not grounded, and our jump time counter is still greater than 0, then our calculated jump input is going to be our initial jump force times our continual jump force multiplier. This is basically what's giving us our variable jump height. And the next else if statement, we're checking to see if we are jumping, and if we're now grounded again, then we're going to set our player's jumping equals false. And then finally, we return our calculated jump input. And that's it. That's all we did for our jump code. Okay, let's move on. Let's go back to Unity and let's do a playtest. Okay, let's see if our jump works real quick. It appears to be working just fine. I'm going to stand next to these blocks. If I just tap the jump button, you'll see we jump a very small amount. If I hold it, we actually jump considerably higher. So our variable jump height is working just fine. So this game's a lot more fun now. We can now actually jump. Let's test our Coyote Time. If you don't know what Coyote Time is, I know we already did the programming and I'm just now explaining Coyote Time. But if you don't know what Coyote Time is, basically the term used for when you run off an edge in your midair and you jump late. It'll still let you jump. I don't know if you saw that. I'll show you again. Go off the edge and I jump. It still will let us jump. It's just a timer that starts counting as soon as I'm not grounded anymore. If I try jumping within that time limit, it will still allow me to jump whether I'm grounded or not. So I'll show that one more time. Let's go off the edge, and I can still jump. Okay, and finally we have jump buffering, which basically means I do not have to press the jump button as soon as I touch the ground. I can press it just a little bit early, and it will still honor the jump. So if I start jumping a lot, and I start spamming the button, you'll see it'll just jump as soon as I hit the ground. It'll honor it. It just gives it a much more natural feel. So if you look down our inspector panel in this corner, all of our jump variables are here. You can see our timers. See our jump time counter is set to our jump time. Our Coyote Time counter is also set to our Coyote Time, but our jump buffer time is set to 0 currently. So if I press the jump button, you'll see the jump time counter will start counting down. Basically, that's just a timer that's going to count down the amount of time that we're allowed to apply a jump force to our player. Once that timer reaches 0 or below, it's no longer going to apply our jump force. Next, our Coyote Time, if we're standing on a ledge like we are now, or even if I jump, it doesn't matter as long as I'm not grounded, the Coyote Time timer will start counting down. If I press the jump before it hits 0, it will allow me to jump. So if you watch, you'll see the Coyote Time will start counting down. And then the jump buffer, the way that works, if I jump, so I'm holding the jump button, and if I let go of the jump button during a jump, and then press the jump button again, it'll start counting down. And if we hit the ground within that, currently that 20th of a second timer, then it will jump as soon as the player is grounded again. So if I start jumping, if I press it twice, I'm pressing the jump button twice on my controller, I don't know if you can hear that. But I'm definitely pressing it a little early. You can see the counter actually starts. And as long as we land before that counter gets to 0 or below, then it will jump as soon as the player is grounded. Now that we have the code laid out, and I've demonstrated what each thing does, let's go back to the code and let's look at it a little closer, a little more in depth. Back in our humanoid land controller script now, let's take a closer look at these counters, because I know I just brushed over them real quick, and then we'll come back and we'll look at these if and these else if statements, just so that we can see how exactly this is working. So we'll scroll down to our set jump time counter function. In our set jump time counter function, if our player is jumping but our player is not grounded, then we need to count down our jump time counter. Otherwise, our jump time counter is being reset to our jump time. So again, our jump time counter is just a counter that is limiting the amount of time we use to apply a jump force to our player. So it's literally the amount of time that we're jumping up and applying a force. So if our player is jumping and we're not grounded, we want that counter to be counting down. And to count down, we're going to use our time.fixed delta time. And again, if we're not jumping, then this counter doesn't need to be counting down, so we want to make sure it is reset to its normal value. And that's what this line's doing, so it's as simple as that. Next, our Coyote Time counter, if our player is grounded, we don't want it to be counting down, we want it to be set to its normal limit. So that's what we're doing here. Otherwise, if we aren't grounded, then we need to be counting down. And if we are pressing the jump button before this Coyote Time counter counts down to 0, then it will allow us to jump. And then finally, this one's a little more complicated, our set jump buffer time counter function. So a jump buffer is allowing you to press the jump button before you can actually jump. If you press the jump button within a certain amount of time before you're able to jump, as soon as your player is able to jump, he will jump. So it just gives a little bit of forgiveness if you're not perfect on the timing of your jump button. And we're doing this with an if statement. If not, jump was pressed last frame. So what we're checking for here is we're checking for the reset of the jump button. We don't want the player to be able to just hold down the jump button and keep jumping. We want them to actually have to press the jump button, release the jump button, and press the jump button again to execute a new jump. So that's what that's doing. And input jump is pressed, so if we didn't press it last time, and we're pressing it this time, then our jump buffer time counter is going to equal our jump buffer time. I'll explain this one more time. If we were not pressing the jump button the last time we came through this code, but now we are pressing the jump button, so there's a jump button reset, then we want to make sure we're setting our counter to our jump buffer time so it can start counting down. And next we have an else if statement. Let's check and see if our jump buffer time counter is greater than 0. If it is greater than 0, then we want to go ahead and subtract from it our time.fixed delta time. So we start counting down. This doesn't need to be an else if statement, this could just be an else statement. I don't like it constantly counting down when it doesn't need to into a negative value. So I'm basically limiting this to a 0 or slightly below 0 value. That's all that's doing. Again, this could just be an else statement. You don't have to limit it. But like I said, I just don't like it counting down endlessly. And the reason why it could be a slightly below 0 value is because say we have a very small amount of time left on our timer, but our time.fixed delta time that we're subtracting from it is greater than that small little bit that's remaining, then it's going to give us a negative value, obviously. And then finally, we're just catching for the next frame whether the jump is pressed on this frame or not. So this one line is controlling our entire jump reset, and that's pretty much it. So if we go back up to our main player jump function, if our jump buffer time counter is greater than 0, so this is what's controlling our jump primarily. If our input.jump is pressed is true, then if you remember, we're setting our jump buffer time counter to our jump buffer time. So we're starting the counter. And if we aren't already jumping, and if our Coyote Time counter is greater than 0, again, same thing with Coyote Time counter. If we go off the ground, we set our Coyote Time to the amount of time that we want, and from there it starts counting down. If that time is greater than 0 still, then we want to be able to jump. So basically what we're saying is, if we're trying to jump within a jump buffer time, and within our Coyote Time, and we're not already jumping, then we're going to jump. And we go through and we do our jump. We need to make sure after we start jumping that we're setting our jump buffer time counter and our Coyote Time counter to 0, because we don't want to come back through and be able to jump again. So next time through, this criteria will now be met. Instead, we'll come to this else if statement. If input jump is pressed and player is jumping and player is not grounded and our jump time counter is still greater than 0, then we're going to apply our force that makes our variable jump height. So all this is doing is checking to see if we're pressing our jump button still, and our player is jumping, and we're not on the ground, and if our jump time counter, which is what keeps allowing us to apply force, if our jump time counter is greater than 0, we're going to keep applying force because we're still jumping. Else if player is jumping and player is grounded, then player is jumping equals false. So this is ending our jump basically. If our player is jumping and our player is grounded, that means that we no longer want to be jumping, so we want to make sure we set our jumping to false. This player's grounded check can run into issues. You might need to change that for your needs. This is just a simple way of doing this, but for example, say you're standing up on a skyscraper, you jump off the edge. Do you really want to be considered still jumping even while you're falling that entire time? Probably not, so just a thought, just a note. You may want to determine this some other way. But for now, this is just fine. And yeah, that's pretty much it. That's how we're doing our jump variable height, our Coyote Time, and our jump buffering. Okay, now that we have the basics of our jump out of the way, let's move on to a bug that we have left over from our slope handling code. But first, so I can demonstrate it a little bit better, we're going to reduce or just change our gravity values a little bit. So if you'll select, in the hierarchy panel, your player game object that has the humanoid land controller script attached to it. For us, that is the red game object here. And in the inspector panel, we'll scroll down to our humanoid land controller script section. And under gravity, I'm going to change some values. Of course, you can change them to whatever you like. But like I said, I just want to decrease the gravity a little bit just so I can show you better what's happening. And here we are in the game. We're at the top of this slope. The slope angle is 55 degrees. Our maximum slope angle is set to 47.5. So this slope is greater than our maximum slope. And the bug that we have that we're going to fix here is that if I go down this slope, which is greater than our maximum slope angle, our movement is going to be modified incorrectly, and it's going to cause us to hop quite significantly. So if you watch, we'll go down the slope. You can see we're hopping terribly. And also, I wanted to show you in our scene panel here, because that shows our debug draw arrays. It'll depict what exactly is happening with our player's input, what kind of force is being applied to our player. And if I go down the slope here, you'll see that our debug.drawArray will not be parallel with our slope and will instead be pointing out into the air, which is causing our player to go out in the air, and then the gravity brings them back down, which is what is causing the hop. So here we go, we're going to go down now. If you watch closely, you saw those red lines and they were not parallel, so what is happening here? Well, let's jump over to our code and let's take a look. Here we are, once again, our humanoid land controller script. In our player slope function here, we're going to scroll down to where we're checking to see if we're on a ground angle or not. We do not want the first statement, we want the else statement. We're checking to see if our ground slope angle is less than our max slope angle. If it is and we are moving, then we're going to apply our gravity grounded. Otherwise, we're going to take our calculate player movement.y, which again is our players up and down, and we're going to override it with our own made up value, whatever that may be. This is a problem. If we're going up the slope, this is fine. It's going to make us go back down the slope, but if we go down the slope, then it's going to mess up our input. Fortunately, this is a pretty easy fix, and I'm going to go ahead and show you how to do that now. And as you can see, this was a pretty easy fix. All we did was we created a float called calculate slope gravity, and we're saying it equals our ground slope angle times our negative 0.2, which is exactly the same value we were using before. Next, we're doing an if check to see if our calculate slope gravity is less than our calculate player movement.y. If it is, then we're going to apply our calculate slope gravity to our calculate player movement.y and completely overwrite our original calculate player movement.y value. So basically what we're saying is if our calculate player movement.y gravity is greater than our calculate slope gravity, then we don't want to overwrite our calculated player movement.y. We want to keep that value because that value, again, we've already calculated the slope angle and we've already modified our input value to take into account that slope angle. So we're already moving perfectly parallel to that slope. We don't want to overwrite that. But, our calculated slope gravity is actually a higher value than our calculated player movement.y for whatever reason, then we want that to apply. That way we don't just sit stationary on the slope, we'll actually go down at the rate of our ground slope angle times negative 0.2. Hopefully that makes some sense. I know it's starting to get a little more complicated. Play with the code a little bit, I'm sure you'll figure it out. It's pretty simple once you get it. And if you are struggling to grasp some of these concepts, it's probably not you, I'm just terrible at explaining things. Why am I making these videos? And to show you that that actually works, here we are back on top of our 55-degree slope again. And if I tell our player to go on the slope, I've stopped pushing any buttons. You'll see it actually does move down. You can see the red lines applying the slope gravity. If I try to go up it, you'll see that it adjusts a little bit, but we still cannot go up it. However, if I go down it, you'll see the red lines are perfectly parallel again. So we're no longer overwriting our calculated player movement.y. Our player's up and down when we don't need to be, or when we shouldn't be rather. So that is now fixed, which leads us right into the next thing that we're going to look at, jumping up slopes that are too steep to climb. Do we really want our player to be able to jump up slopes that we shouldn't be able to climb? I don't know, that's up to you. For dev purposes, I like having the ability, it just makes things a little simpler. But I will now show you the code to limit that so that you cannot jump up a slope that is too steep. If you want, you could even assign a different variable altogether for this so that it would be different from your max slope angle. You could have like a max slope angle to jump variable if you wanted. The possibilities are there and the options are limitless. Anyway, let's jump back over our code and take a look at doing that. Back in our humanoid lamb controller script, in our player jump function, in our first if statement, which checks to see if we are start a jump or not, we're going to add another if check, basically checking to see if the angle of the ground we're on is greater than our max slope angle. If it isn't, then we will allow the jump. If it is, we are not going to jump. It's really as simple as that, so here we go. As I said before, this is the exact same check that we're doing in our player slope function. So if you wanted, you could cache this somehow. That way you don't have to do the math twice. This is quite inefficient and completely unnecessary. But I just wanted to show you the actual code itself. And like I said, I'm not going to be using this for now, so I'm actually going to comment this out. But this is the code right here. You just need to do this simple check, and that will stop you from jumping up any slopes that you shouldn't be able to jump up. And as I mentioned before, just swap out that max slope angle for a different variable if you prefer, and it makes it just that simple to implement. Alright, so let's go back over our game again, and let's make sure that that's working. So here we are at our 55-degree slope, and we're going to try to jump up it. I'm sure you can hear me pressing the button. I cannot jump it until I'm actually on the ground. And if I try on the 50-degree slope, it's not going to work. But if I go over to the 45, it's going to work, as well as the 40, and the 25. So again, that's simple to implement. I'm going to leave that disabled for now because for now I won't be able to jump up these slopes. It just makes my life easier. So I'm just going to comment this out real quick. Additionally, while we're here, there's one more thing I'd like to add to this script. Currently, if we're jumping or falling, or if we're just in the air in general, we can still move in any direction we want at the same speed. Maybe you'll want the character to slow down, to move slower in the air, or even speed up. Personally, I'm going to make the character speed up. So yeah, let's just go ahead and do that real quick. This is a pretty easy implementation. If we scroll up to our player move function, and in our player move function, if you remember when we programmed this, I mentioned that we don't need to multiply our y by our movement multiplier because our y value at this point is going to be a 0 anyway. So I left the code like this just to make sure that you were aware of that. It does make it kind of nice to be able to just look at this and be like, hey, why is that like that? It makes you ask the question, but this is really something that's pretty basic. So at this point, hopefully you get that. We're going to go ahead and wipe this out, and we're going to put a different line of code here. And all we did here is we basically added an if-else statement. If our player is grounded, then our player move input is going to be multiplied by our movement multiplier. Else, if we are not grounded, if we're in the air, then our player move input is going to be times our movement multiplier, also multiplied by our not grounded movement multiplier, which we still need to define. And one other thing I just noticed is that these are not in the right order. I like keeping them in the order that I execute them, our actual functions, so I'm going to switch this and move it down below our player ground check function. Okay, now let's go add our not grounded movement multiplier variable. We're going to add it right underneath our movement multiplier variable. And that's it. Now if we're not grounded, we're going to get a 25% increase in movement force being applied to our character, so we will move faster anytime we are in the air. Obviously, if you wanted to move slower, then you would just change this to a 0. But, like I said, I want to move faster, so we're going to change that back to a 1, so that we get 125% basically. Hopefully that makes sense. Let's go test it now. Okay, now when we move around, we should be moving 25% faster than what we do when we are grounded. So if I jump a lot, you can kind of notice, you can see that there's a slight speed increase when I am in the air. I think it's pretty noticeable, so it's definitely working as intended. Again, you could use that to slow it down, or you can just leave it as it is. You can do whatever you want with it. One other thing that I'd like to point out while we're here to close out this video is that if we are on a slope and we're just going to stand stationary, if all I do is I press the jump button, and when we land, inertia forces us down the slope. I'm perfectly fine with this. If you remember, we have no friction on any of our surfaces, so it's like standing on ice. And if you're standing on a 25-degree slope covered with ice and you jump up and come back down, what do you think is going to happen? So this is perfectly fine. This is perfectly acceptable. I'm okay with this. This is not a bug or a glitch. This is working as intended. So with that, I'm going to wrap this video up. This video did end up being a bit longer, but I hope I was pretty thorough in the explanation. Please let me know if you have any questions in the comments below. The next video is going to be a fun one. We're going to be implementing some physics-related stuff that's going to be some fun to play with. I'm not going to go in details right now what exactly it is, but you can kind of see from the preview that you're seeing on your screen right now. But yeah, looking forward to it. I hope to see you then. If you're feeling generous, leave a comment down below. I want to read what you're thinking. Let me know if you have any questions or recommendations. I'd also appreciate it very much if you liked the video. And if you're feeling extra generous, it'd blow my mind if you subscribe to the channel. Being new to this and putting these videos together takes a lot of time and effort. Thank you for any and all participation and support. I look forward to continuing this in the next one. See ya.